Alrighty, here we are again. Let's get even more into the graphing of quadratics. We did that intro, looking at axis of symmetry, looking at vertex, looking at the a values. Now let's just graph the whole thing. So to do so, let's first look at our learning objective. I can graph quadratic equations. Let's remember we have our axis of symmetry, which is that invisible line right down the middle of our quadratic graphs, cuts it in half and makes it identical on both sides. That axis of symmetry goes right through the vertex of our quadratic, which is either the maximum or the minimum value of our function, of our graph. In this case, it's the minimum value. And then we also have intercepts that we could find by plugging in 0. If we're looking for y-intercept, we plug 0 in for x. If we're looking for x-intercepts, we plug 0 in for y's. And remember, those x-intercepts, they were our solutions. So looking at some of the steps for graphing, we're going to graph by finding 5 points. And the first point we always want to find is the vertex point. So we're going to start with that axis of symmetry, plug it in, find the y value. There's our vertex. From there, we're going to use the a value to find 2 more points really quickly. So the first 3 points will be done fast as long as we can find the vertex. And then from there, we just find 2 more points. Most likely, those other 2 points are going to be x-intercept points. So we're going to be looking for solutions. Let's go to delta math. Let's look at an example here. So on delta math, I have the equation y equals x squared plus 12x plus 35. Y equals x squared plus 12x plus 35. X squared, 12x, and 35. Okay, now we want to use our axis of symmetry equation to find the axis of symmetry so we can find the vertex. So I want negative b, which is going to be negative 12, divided by 2 times a, and this a value is that invisible 1. Negative 12 divided by 2 times 1, which is just 2, becomes negative 6. So now we take negative 6, plug it right into our equation. Negative 6 squared plus 12 times negative 6 plus 35. Negative 6 squared becomes 36. Ooh, what's 12 times negative 6? Negative 72 plus 35. I'm going to take care of the positives first. 30 plus 30 makes 60. 6 plus 5 makes 11. 11 plus 60 makes 71, right? So I have 71 minus 72, which equals negative 1. So my vertex is the x value and the y value we just found. My vertex is negative 6, comma, negative 1. So let's use that vertex and let's put it on our graph. We said negative 6, negative 1. Negative 6, negative 1. There's my graph. Okay. Now, the next points we could find by using the slope of our quadratic equation. Our a value was that invisible 1 x squared. So what I'm going to do is I'm going to use that 1 as a slope. 1 is a rise of 1 over 1. And I could do the same thing going the other way because it's symmetrical, because it's the same distance on both sides. So I have 3 of our points, and it looks like our graph's going up, which we should have predicted, right? Because we have that positive 1, so we're going up there. Let's find another one by plugging in values. I have negative 4 next, so let's plug in a negative 4. That becomes 16. I better work that one out. That becomes negative 4 squared plus 12 times negative 4 plus 35. Now, maybe I should slow down a second. I picked negative 4 because it's the next point to one of the clean points I have already. I don't want to pick 0. That's going to give me a huge y value or anything past beyond there. I want to deal with smaller points that's close to my graph. So I picked negative 4. Solving this thing, I get 16. 12 times negative 4 is negative 48 plus the 35. Let's go 16 plus 35 here. 6 makes that 41, so 51. minus 48, which makes 3, right? Oops. So at negative 4 x value, we're going to be at 3 y value. So our next point is going to be negative 4 comma 3. Negative 4 comma 1, 2, 3. I could be the same distance away and make my graph. Let's see. There we go. Another way you could do it, guys, take a look at Delta Math. They're just going to plug values in. They plug in negative 7, negative 6, negative 5, negative 4, da, 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 da. They get their y values. They can plot those points there. But if you use my 5 points, it's a little bit easier to do. You don't have to plug all these values in. You just find your axis of symmetry, then your vertex, then you find your x-intercepts, or you go beyond by just one value, plug it in, find the y, and then you could just bounce over to the other side. All right, that's it. Guys, take care.